Hello, good to be back. Hope you're keeping it cool. I have the pleasure of interviewing Javier here. Javier is with SoftBank. He is an operating partner, but more importantly, Javier is deeply involved in the Stargate program. For those of you that don't know what Stargate is, it is the program announced by President Trump recently as the SoftBank investment into building AI data centers right here in the U.S. And a commitment of $500 billion. That's $500 billion. And so Javier is deeply involved in the project and super excited to have him share our insights. So welcome, Javier.
Thank you. Thank you for having me here. As you mentioned, we're big believers that AI infrastructure is critical infrastructure in today's world. And we want to be part of building this infrastructure going forwad. We think that AI infrastructure is kind of the railroads of the 21st century. And it's going to be these railroads that is going to power a lot of economy sectors in the next few years.
So I'll get straight to it. You announced the $1 trillion Arizona, Illinois AI Robotics Hub. How real is it? What kind of power are you looking at for the $1 trillion AI hub? And I believe this is first of its kind in the world.
We at SoftBank have been investors and big believers in robotics for many, many years. Again, we have an extensive portfolio of robotic solutions that have been deployed in multiple applications. And we think that AI is going to create a new revolution in robotics. We're going to have, intelligent robots that are going to be useful in manufacturing, in production, in multiple areas of the industry. So there's obviously a big bet on building robotic capacity to power this infrastructure. Think about, you mentioned before Stargate, you're mentioning, billions of dollars in AI data centers. You have multiple bottlenecks when you build data centers. You have power, you have cooling, you have interconnectivity, right? But if you start thinking in a more basic and pragmatic way, you have a bottleneck on the actual assembly and build up of the physical infrastructure, right? So if we're gonna innovate in terms of the way that these racks, these configurations of the GPUs are going to be built. If we're talking about liquid cooling, immersion cooling, and advanced technologies that might be still in research, you need a different way of manufacturing these data centers. Right? Things where robotics will be the main enabler. So if you think about it from the SoftBank point of view, these are just components of the whole vision of powering today AI and AGI in the future.
Amazing. You also have an incredible clean energy portfolio. I mean, I believe the 1.2 gigawatt energy deal that you have in Texas. What are some of the lessons you learned from developing this like multi-site power purchase agreements, and what are your general thoughts on renewables through solar versus small modular reactors that can produce like 24-hour continuous power? And as I know, solar is great for residential, but when you're doing utility scale, 1.2 gigawatts, you're looking at essentially a nuclear reactor, and let's say it's a massive capacity. So what are some of your lessons? Walk us through.
So again, SoftBank also a major investor in energy for many, many years. Probably one of the most unknown areas of our investment portfolio. We have learned how to develop, how to finance these deployments in different places in the world, in Japan, in India, in the US. We believe that solar and in general renewables are not the solution for the energy bottleneck, but are a component of it, right? We believe in a hybrid energy infrastructure where you're going to have things that are optimized for training, where you have these spiky consumption, where you need to have constant the energy levels for certain times. But on the other side, you have inference, where the inference consumption curve is flat, where you probably need other ways of power that. So we believe there is a space for everything. I think what you need is access to all these solutions. We don't believe in vertical integration 100%. It's not that we build the energy so we can build the data centers. I think you have to optimize the data center location based on the availability of the kind of energy that you need. You need it for inference, you need it for training, then you locate your sites where you have access to it. On the other part of the question, we think that when you're looking for energy solutions, nuclear is probably underrated, right? I think a lot of people is rediscovering nuclear. Nuclear has had a little bit of a gray cloud on top of that, but at the end is incredibly efficient, is cheaper, and there is so much work, so much research on the nuclear side that maybe not today, maybe not in 2 years, but maybe in 4 or 6 years, we're going to have solutions that are going to completely transform that side of the equation.
Amazing. So,
you have seen some companies already there, right? Like you have seen even OpenAI or some investing in these new nuclear solutions because it's going to be a definite component going forward.
Yeah, considering the energy need, particularly concentrated energy need for training is doubling every 2 years. So the expectation by 2030, the only way to train the state-of-the-art model is with a gigawatt supply. So nuclear will be the only way to do so. Unfortunately, the last nuclear reactor we built in America took about 14 years, right? And the interconnect requests now average anywhere from 10 years here for new data center builds. I mean, Jason earlier gave a slight insight into how hard it is to build new data centers. So from a policy standpoint, what are some of the things that the SoftBank is focusing on to reduce the interconnect queues, perhaps? Or what are some creative solutions that you're looking at to solve these like heavy regulatory burdens that we have?
Again, how the entire industry is looking for almost like a public-private partnership, right? Identifying these bottlenecks and identifying where the local, state, and federal government can help is important, and then working together with the government, considering, again, this is critical infrastructure, right? We're not building something for the sake of it. We're not building something because websites will be faster or more efficient. We're talking about really the engine of an industry that is going to transform the economy. So we're looking at the help of the government on interconnect, on the regulatory permits in order to build some of these sites. There are manufacturers, there are implementers of energy solutions in Korea, in Japan, in other places that could probably shorten those development times to maybe 3-5 years. But you need to work alongside the government in order to get these things in place in terms of certification, in terms of the access for these technologies to come into the U.S.
And what's the general sentiment been in your experience working with the current administration in terms of speeding up some of these regulatory asks?
Again, everybody in the industry needs to work with the administration. I think we have an administration that has already delivered the message that AI is important, is critical. And I think, I don't want to get political here, but every message that we have heard from the administration is they want to remove all the barriers that will be a roadblock for the deployment of AI infrastructure. So we work, and we have made
things right in the next few years. When it comes to chips efficiency, right? So this obviously, the need is exponentially growing. What are you looking at in terms of how efficient the chips are getting in terms of like extracting more or extracting more intelligence per joules, right? So I know you made some investments into Ampere and whatnot. So if you want to talk a little bit more.
Yeah, I think this is the other important component of the whole equation is we're looking at architectures that have been used in AI for a few years. But there is a lot of research around, neuromorphic implementations. There is stuff out there where you can change in some way the way that power and compute are related to each other right now. Right now, you're using power for the compute. You're using power to remove the heat for the cooling. You're using power for the interconnect, the memory, all the different components. And that gets you this horrible exponential, formula in between power and the number of teraflops that you can get out or the number of tokens that you can process in a rack. If you rethink the problem and you start building the architecture in a way that is more energy efficient, then you could completely transform again the industry. And maybe the levels of power that a lot of people is anticipating, maybe we're not going to get there, at least in the probably 5 to 6 years, right? I always use the analogy of the computer architecture for CPUs, right? Intel, was the leader in desktop computing for decades, right? And then suddenly, the mobile revolution came, and mobiles needed to complete a complete rethinking of the computer architecture. And this is what made ARM the company that is today, right? They developed a solution that was energy efficient first and became basically the architecture that powers 90+% of the mobile devices around the world. GPUs started to be popular for gamers, and they were intended to render and to do ray rendering and stuff like that. And then we found another purpose for them in AI. We have made investments, and the industry is making investments in companies that have technologies and architectures that are built for AI from the ground up. And again, there are multiple companies out there, a lot of research out there. You have the Cerebras of the world, you have the Sambanovas of the world. All of them are trying to solve this problem. The moment that you can reduce the number of watts that you need to process X number of tokens, then you change the game again.
Yeah, amazing. But also there's this Javon's paradox, right? The more efficient something gets, more usage it gets. I mean, I always want my ChatGPT to go faster. It just wouldn't go. But I'm able to do a lot more things that I couldn't.
And there is a lot of work also on the models, right? And you don't need to run, ChatGPT 4.0 for everything, right? You don't need to run very sophisticated, complicated video models to serve certain basic applications. So there is a lot of work still that needs to be done on finding the right infrastructure for the different problems. I think right now we're using very sophisticated, complicated, broad use and expensive infrastructure to solve very simple problems, right? I work very closely with a company that does image editing, has a consumer app for image editing. They are running APIs in the back into VO or Runway or things like that. It is expensive. I think there are other ways. There are small form factor language models. There are other technologies that are going to make this usage more efficient.
Awesome. So final question, Seth. What are your thoughts on decentralization in terms of energy? So small microgrids producing or capturing energy, maybe even consuming at the edge, and interacting in a peer-to-peer manner, maybe contributing back to a larger hub. Have you seen these kind of deployments, or what's your general thoughts on how you look at returns?
I haven't seen anything. Again, I listened to the previous presentation from Daylight. I think the idea is genius. Again, going back to the idea that there is no perfect solution for everything and all the solutions need to collaborate and needs to be a hybrid approach. I think in the compute, centralized and decentralized will be complementary. There's going to be applications where only centralized works at an efficient level, and there are applications where decentralized will be cheaper and will be the optimal solution. I think we're big believers in decentralized physical infrastructure in general, not only for AI, but for compute and telecom and all these different things that are out there. So on the infrastructure side, decentralized makes sense. On the energy side, the same thing, right? If you can crowdsource energy in a very efficient way, low cost, to power either individual implementations of data of compute or mid-sized data centers, it will just make that component of the P&L for these providers of compute, it will make it smaller, and therefore it will make it easier to finance. It will make it cheaper for the end consumer, and it becomes kind of the flywheel for the adoption of AI.
Awesome. So now we're going to switch to rapid fire. 3 quick questions. One bet you would make today about AI-driven energy demand in 2030?
I think I have read 30% of the total 30%. US. That's 30%. That's what I have seen. I think we're going to be there. Anything in between 20 and 30% of the total energy.
I think I'm aligned with you there. I mean, Department of Energy report recently said 12%, and DOE is known to take very conservative approach, and they always miss their estimation. So when DOE says 12% of US energy will be consumed on AI by 2028, I think in reality it'll be 30% by 2030. So that's a great prediction.
Again, is the way that innovation is moving in this space is something that we have never seen. This accelerated pace of innovation. Everybody is discovering, these tools at a pace that we have never seen before. Right? I always tell the story. It took my mom 10 years to write her first email since the first time that I opened a Gmail account for her, right? It took her 3 months to start talking to ChatGPT in a daily basis, right? My mom lives by herself. She talks to ChatGPT as kind of like a significant other that is always at home. And that level of adoption, and we know how much compute that requires, right? That level of adoption immediately gets reflected on the energy consumption in the short term because we don't have any other solutions that are better than.
It's incredible, yeah. What's the most underrated technology lever for slashing joules per interface?
I think at this point, probably the chip architecture and the way that you do the cooling, right? I think the moment that you can optimize the extraction of the heat from the chips by, again, changing physical architecture, doing cooling as close as you can to the die, using different materials, moving from copper into graphene, things like that. That physical part, I think that's what you get a lot of that, right? I would think those are relatively easier things to be implemented in the next couple of years.
On die cooling, like what LVL72s are going after, correct. Seems to be a trend. Yeah. Makes sense. Third question and the final. If regulators could fix one bottleneck tomorrow, what should it be?
Again, I think we talk about it in the energy side, just allowing technologies like nuclear, small modular reactors, and nuclear developments to be deployed in a relatively fast period of time. I think that's going to be key. Again, other stuff is very basic. And you're building these massive data centers. You need simple permits. Like you're talking about construction permits. Those things, depending on the jurisdiction, could take a day, a week, a month, or a year. So kind of all these components of that machine on the permitting side, on the enablement side, particularly when the purpose is powering this critical infrastructure. If everybody in the government side thinks that they are contributing to this infrastructure and they act accordingly, I think it will really compress the time of deployment.